Hey everyone, and welcome back to the channel. If you're a Tesla owner or a mechanic working on these amazing EVs, you've probably come across a few unique challenges. Today, we're diving deep into a common but sometimes tricky fault code, B11C7, which points to a problem with the cabin heater control circuit. Specifically, the code means the high voltage cabin heater control signal is too high, or there's a short in the circuit. So, if you've got a Tesla in your bay with no heat, and this code is staring you in the face, stay tuned because we're going to walk through the entire diagnostic and repair process step by step. First things first, what exactly is this B11C7 code telling us? In simple terms, the car's computer has detected an electrical fault with the positive temperature coefficient, or PTC, heater. This isn't your old school heater core with hot coolant running through it. Teslas use a high-voltage electric heater to warm up the cabin quickly and efficiently. The B11C7 code is a major clue that something is wrong with the signal that tells this heater what to do. The signal voltage is higher than the expected range, which usually indicates a short to power or an internal failure within the heater unit itself. So, where do we start our diagnosis? The first step is to locate the component in question. The PTC heater is housed within the main HVAC unit, usually located under the dashboard. Getting to it can be a bit of a job, often requiring the removal of the front liner and some other panels to access the top of the HVAC assembly. Before you start tearing anything apart, always, and I mean always, follow the proper high-voltage disabled procedure. We're dealing with dangerous levels of electricity here, so safety is your number one priority. Put the car into service mode. Disable the high-voltage system, and verify that it's de-energized using your Cat 3 or 4 rated multimeter and proper PPE. Your safety is not worth cutting corners. Once the vehicle is safely powered down, you can begin your visual inspection. The main connector for the PTC heater is where we'll focus our attention. Look for any signs of damage, corrosion, or pushed out pins. Water intrusion can be a big problem in this area, so check for any telltale green, crust, or moisture around the connector. A poor connection can cause all sorts of weird signal issues, including the circuit high fault we're seeing. Give the wiring harness a good look over as well. Trace it back as far as you can, looking for any chafing, pinching, or signs of rodent damage. Sometimes, the problem is as simple as a damaged wire making contact with another power source or the vehicle's chassis. If the visual inspection of the connector and wiring doesn't reveal any obvious problems, our next step is to check the power supply and fuses. The PTC heater runs on high voltage, and it's protected by a dedicated high voltage fuse. You'll need to consult the specific service information for the model you're reworking on to locate this fuse, as its position can vary. It might be in a high voltage junction box or a pyrofuse assembly. Carefully test the fuse for continuity. If the fuse is blown, that's a strong indication of a dead short to ground within the heater unit itself. Don't just replace the fuse and call it a day. A blown fuse is a symptom, not the root cause. You need to find out why it blew. Now, let's say the wiring looks good and the fuse is intact. At this point, all evidence is pointing towards an internal failure of the PTC heater unit. The control module inside the heater assembly is likely the source of the circuit high signal. Unfortunately, these are not typically serviceable components. The most effective and reliable fix is to replace the entire PTC heater assembly. This involves removing the old unit from the HVAC case and installing the new one. It's a bit labor-intensive, but it's the correct repair. So, to recap the fix, if your B11C7 is caused by damaged wiring or a bad connector, you'll perform a professional wiring repair using approved methods like solder and heat shrink. Never use simple but connectors on these critical circuits. If your diagnosis points to the PTC heater itself, replacement is the way to go. After you've replaced the heater and reassembled everything, don't forget to follow the procedure to re-enable the high voltage system. Then, clear the fault codes and perform a functional test. Turn on the cabin heat and monitor the system's operation. You should have warm air, and the B11C7 code should not return. And that's a wrap on diagnosing and fixing Tesla fault code B11C7. It might seem intimidating because it involves the high voltage system, but by following a logical process and prioritizing safety, it's a very manageable repair. Remember, locate the component, inspect the connections, check the fuses, And if all else fails, replace the heater. Thanks so much for watching. If you found this video helpful, give it a thumbs up. And be sure to subscribe for more deep dives into EV repair. Drop any questions you have in the comments below.